My name is Ashish Kumar. I'm Assistant Professor, Department of Computer Science Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. My subject is Operating System. Subject code is BCS 401. Today, my third lecture, my lecture topic is Deadlock. In that topic, I have discussed here about Deadlock system models, Deadlock characterization, prevention, avoidance and detection, recovery from deadlock. First, you mentioned deadlock. What is generally all of you know that what is a deadlock? First, you consider deadlock means if one resource cover from one process and another resource cover from another process, but a need of one process P1 process need of that resource that is covered from the P2 process, but P2 not release the resources. That means that condition it create the stuck condition, and it is a create the deadlock. Basically, here some take the one example here mentioned. Two process each want to record the scanned document on CD. Process one request for a scanner and gets it. But that means already said the one resource are allocated from the process one. Process two request for the CD writer and gets it. But process one request to CD writer, but process two already hold that resources, and process two request to a scanner but is blocked. That means both are hold one resources, but the requirement of another resources from, but that resource holding by the another process. So in that situation, at this point, both processes are blocked and will be removed of the forever. This situation is called a deadlock. That means it is not release your resources. Why? Because your process is not completed, then your resource is not released. So in that condition, it is called the basically deadlock condition. Scenario of deadlock also already here mentioned scenario. See this picture. In that picture, R1 basically demanded from P1 and P1 resource allocated to R2 and R2 demanded to P2, but P2 resource allocated to R3 and R3 demanded to P3 and uh, R1 demanded to P3. So whole created a cycle but not release the any resources. So it is that condition it is the called the deadlock condition. Here mentioned. Just as you assume that both side, every section a car is enter in a main road, but both sides are uses. So if at a one time all cars are present in the main position, so it is a create the stuck condition and it is a deadlock possibilities here. So the process are the car, the resources are the spaces occupied by the cars, but it is a move on the one times in both all our cars, so create the deadlock possibilities here. Deadlock occurs. Both every car are created the when cover the one position at a time, so it is create the deadlock condition. Sequence of event of user resources request the resource, allocate the resource and release the resource. First, it is a demanded the resource, then allocate the resource, but after working process, after completing the process, release the resource. Sequence of event to use as a resource form. Deadlock characterizations. Here mention first is mutual exclusion. Mutual exclusion, that means at a time one process executed, another process not interfere, and that process is not a and that resource not in a serial mode. That means one time one process are only access. Example here mentioned printer. So here already mentioned at least one resource type in this system which can be used in non-shareable mode, that is one at a time, for example printer. Because many resources can be shared by more than one process at a time. Example memory location. In that diagram below there is a single instance of resources and held by the process one at a time. Next is hold and wait. Hold and wait, that means one process holding the resources and demanding the another resources. That is a holding condition. Here also in through this figure, resource 1 allocated to process 1 and process 2 request to resource 1 and allocated resource 2 and resource 3, but process 1 resource 1 allocate to the, so that its situation is creating the holding situation, hold and wait situation. No preemption. No preemption. A resource allocate to any process in that times, if process not executed, so resource is not released. No interruption is possible in non-preemption condition. In a running process not interrupted after completing process, that it is a release the resources. It is a main function of the non-preemption. A resources can be preempted from a process by a force. A process can only release the resources voluntarily. In the diagram below, process 2 cannot be preempt resource 1 from the process 1. It will only be released when process 1 relinquished it voluntarily after its execution is completed. Circular wait. Circular wait, if one process hold one resource, another process holding another resource and demanding one-to-one resources required. So it is create a circle form. So that means circular wait, two or more process must form a circular chain in which each process is waiting for the resources that is held by the next member of the chain. All four of these conditions must hold simultaneously system for a deadlocks occurs. Next is handling deadlock. How to handle deadlock? Some points are given here. Handling the deadlocks. First is prevention, avoidance, detection, recovery, ignore. Prevention, that means constraints are imposed on the way in which process requests to order and prevent the deadlock. In sequence manner, avoidance, resource are carefully allocated to avoid the deadlock. That means avoid the deadlock. That means we follow the one road, then move on the another road. So that is the avoidance of the resources. Detection and recovery. Detection and recovery is the major point detecting from the deadlock condition. Deadlock are allowed to be occur, and detection algorithm used to detect in after deadlock is detected, it is resolved by certain means. Next, ignorance. Do nothing, just ignore it. Here, first, deadlock prevention. Deadlock prevention can prevent by violating the one of the four conditions that leads to deadlock: attacking the mutual exclusion condition, hold and wait, no preemption, circular wait. These four conditions of deadlock. If one condition it is wrong, then deadlock it is not occur. So if deadlock, that four condition is true, then deadlock is occur. Violation of mutual exclusion. That means how to remove mutual here mentioned before slide ki how to deadlock prevent. So that means prevention is possible. First ki in four condition you have to four condition, word condition is false, then deadlock is prevented. To here mention some violation of mutual exclusion of condition. No deadlock if each resource can be assigned to more than one process. Each resource can be, that means resource is shareable. This can violate the hardware properties of resource. We cannot assign some resources to more than one process. Time such as printer not feasible. That means that the possibility, not possibility. So mutual condition is not false. So next is violation of hold and wait. Hold and wait, that means process allowed to start execution if and only if it has acquired all the resources initially positioned. That means no hold and wait condition are created. A process is allowed to run if all resources needed is available. Otherwise, nothing will be allocated and it will just wait. Problem with this strategy is that a process may not know required resources at a start of run. resource will not be used optimally. Optimally that means in right way. It may cause starvation of the process that need maybe resources. Violation of hold and wait condition. Hold and wait, that means no hold and wait condition. Wait timeout. A process will, here we already hold and wait condition. Hold and wait, that means a resource created as a priority base. So also is not create the hold and wait condition. Do not hold. A process will acquire all desired resources, but before making any fresh request, it must release all the resources that it currently holding. Wait timeout will place of the maximum time up to which a process can wait, after which process and release all the holding resources. No preemption. No preemption, that means forcefully we have to break the process in a running condition, because high priority of process if enter, then normal process are basically stopped and high priority process is running. So it is a forcefully preempt the process in case of no deadlocks. We allow to process forcefully preempt resource by the others. Circular wait, that means yes, circular wait here. Circular wait means, that means basically here some resources are mentioned, mention 1, 2, 3, 4, 5 resources and give the some priority in an increasing form. And if P1 process use the R1 resources, then next is R2, R3 and R4 resources are allocated. Not, R3 resources are using, then R4, R5 resources are assigned to P1, not to 1 and 2 resources, because it's an increasing form. So here already mentioned in the slides, to provide a global numbering of all resources, process can request resource wherever they want to, but all requests must be made in increasing or decreasing, maybe increasing and decreasing order. A process need not acquire them all at once. Circular wait is prevented if a process holding resources and cannot wait for resources if m greater than n. Printer, scanner, plotter, tape driver, CD. This is the resources and give some numbering from 1 to 5. Already here mentioned ki m is greater than n, that means the numbering here mentioned, and here already in last point P1 resources allocated P1, R2, R4 already resources in the possible, not possible in this way. Okay. Deadlock avoidance. In most system, however, resources are requested one at a time. The system must be able to decide whether granting a resource is safe or not, and only make the allocation when it is safe. That means always check the safe or unsafe condition. Deadlock avoidance, basically Banker's algorithm, basically using for the deadlock avoidance condition. Generally use Banker's algorithm, and exam point of view, most of time I see that the Banker's algorithms are using for the avoidance. In a Banker's algorithm, basically I have to find out safe or unsafe state. If state is safe, then deadlock condition is not arise. If unsafe state, then deadlock condition is arises. So here mentioned, a state is said to be safe if it is not deadlocked and there is some scheduling order in which every process can run to completion if all of them suddenly requested their maximum number of resources immediately. Here mentioned deadlock models. Deadlock models, that means the RAG graph, resource allocations graphs. Notation used for the representation of the RAG. Process, it basically it is a circular form, and resource type is basically square form mentioned. So process will resource, and already I am to see this pictures, no problem. Resource allocation graph. What is the resource allocation graph? Basically resource provided to the any process, that is called the resource allocation. Basically whole organizing system are basically depend upon the process using the resources. The resources allocation graph is the pictorial representation of the state of a system. It also contains the information about all the instances of all the resources, whether they are available or being used by the process. In resource allocation graph, the process is represented by the circle, while the resource is represented by a rectangle. Already see in the pictures, previous slide. Age in RAG are also two types. One represented assignment, another represented the weight of the process for a resources. A resource is shown as assigned to a process if the tail of the arrow is attached to an instance to the resources and the head is attached to a process. A process is shown as waiting for resources if the tail of an arrow is attached to the process while the head is pointing toward the resources. Here mentioned. Resource moving on this way, that means resource is assigned to A. Resource is assigned to A. Here mentioned holding a resource, that means resource assigned to A, and requesting a resource. Arrow distance is moving from the resource area, but that means the B is a process and R is a resource. And here deadlock, if create the circle, that means deadlock condition are created. Resource allocation graph, find the system is in a deadlock state or not. Suppose in they way given a figure and most of time asking the questions, use of this figure, please say that this is a follow the deadlock condition or not, it is a deadlock condition. Then you have in that times basically here basically first you check the if graph is follow the cycle or not. If cycle, then it is a deadlock. So here already mentioned the graph is deadlock free since no cycle is being formed in the graph. So here check the no cycle in the graph, that means deadlock condition is free. So here some point are mentioned. Let's consider the P1, P2, P3 and two types of resources R1, R2. The resources are having one instances each according to the graph. R1 is being used by the P1, P2 holding R2. So it basically describe the which process cover the which resources. So and P1 cover R1 resource and it is not demanded the any resources, and P2 cover R2 resource and demanding R1 and only R1, and P3 basically not holding any resource and it is a demanded from the R1 and R2. So basically all of you know that if R1 through the picture, I have to just give the some summary regarding for this problem. Generally basically if P1 holding the R1, so after completion the P1 work, because P1, why P1 working, why P1 the process are completed, because no need the any other resources, so P1 executed. After execution P1, need of R1 is released, R1 released, P1 R1 is released. So if R1 released, so P2 need R2, P2 need R1. If R1 released, so P2 use R1 and R2 already given, so P2 is also execute, no problem. And P3 need R2 and R1. P2 if executed, then R1 and R2 is free. So if R1 and R2 are free, P3 access the R1 and R2 and it is executed. So here deadlock condition, if cycle is forming the cycle, deadlock detection using RAG mein. If cycle is being formed in a resource allocation graph where all the resources have the single instance, then the system is deadlocked. In case of resource allocation graph with multi-instance resource types, cycle is a necessary condition of deadlock but not to be sufficient conditions. The following example, simple example are here, because of this you form the cycle, so it is a deadlock conditions. bankers algorithm. Already have to discuss in case of deadlock avoidance, bankers algorithm is the perform the most important role finding the safe state or unsafe state. If finding the safe state, that is called the no deadlock condition arises. If finding the unsafe state, that means deadlock condition is arised. Okay, here. So bankers algorithm used to avoid deadlock allocated resource safely to each process in this computer system. The S state examine all possible test uh, examine the S state examine all possible test or activities before deciding whether the allocation should be allowed to each process. The bankers algorithm is named because it is check whether a person should be sanctioned a loan amount or not to help the bank system safely simulate allocation resources. The bankers algorithm is a resource allocation and deadlock avoidance algorithm that tests for safety by simulating the allocation for the predetermined maximum possible amount of all resources, then makes an S state check to test for possible activities before deciding whether allocation should be allowed to continue. Bankers, when working with the bankers algorithm, it requests to know about three main things. Three things are mentioned. Basically, one, two, 3. How much each process can be requested for each resource in the system? It is denoted by the maximum request, allocated resource, and availability of the resource. First, maximum resource are allocated, and maximum resource need, allocated resource, and availability of resource. Basically, in 3 points, whole bankers algorithms are working generally. And last point is given, the bankers algorithm is a combination of the safety algorithm and the resource request algorithm to control the process and avoid deadlock in a system. Okay. Here mentioned already, in a bankers algorithm, basically availability, first you check the availability, then maximum need, then allocation of resources of any process, need of resources of any process, and then finish. This 5 process, these 5 conditions are using. Next, here take one example. Basically here take one example. P1, P2, P3, P4, P5 and P5 and ABC are resource. Resource maximum values are given here 7, 5 and 7. Okay. And allocation of resources are given here. Maximum need of any process are mentioned here. Availability are mentioned. In this table, you have to basically initial level you have find to need of resources P1, P2, P3 and P4, just find out. So through this process we have to generally find the need one by one, and the final need here not given in this were not given, just I have to say that how to find, just generally. First you check 3, 2, resource A, maximum number of available resource is 10, but here allocated 3 to 5, 5 to 3 to 5 and 2, 7. Okay, that means A 7 resources are allocated different process and availability is 3 because its value is 10. And another B, P1, B resource 1 and 2 and given the 5, so 3 resources are available. Another C, 2 resources are available in this way. First you find the availability first. Then need maximum 753, need maximum need, but already allocated 0, 1, 0, 2, 0, 0. So in this form we have to write the all situation. First situation need for P1 753 minus 010. That means that 753 minus 010, then you have to find the need 743. In this way, you find the all process are need one by one, and then availability, check the availability which value prefer the fulfill the ability of which process. Then that process are executed, and finally it is a condition is so numerical the bankers are given one by one. Okay. Most time up you see that in the books, one by one given the situation condition are given, different allocation and requests are mentioned in a numerical, and here one numerical is also there. A single processor system, three resource type X, Y and Z. That means three resources of X and Y, Z. Okay, which are shared by three process. There are 5 units of each resources types. Here mention just a minute. Here, suppose suppose this is problem, and but not given the answer. Just have you see the a single process system has three resources type X, Y, Z. ठीक, given three resources X, Y and Z which are shared by three process. Everyone share the three process. There are 5 units of each resource type. Every resource of total number of units is 5. Consider the each resource type allocated to each process. Here mentioned, consider the following scenario where the column allocated denotes the number of units each resource type allocated to each process, and the column request to denoted number of the units of each resource type request by the order to complete which of these process will finish the last. Okay, here mention allocation and request. Okay, so request allocation is given here. P1 already 1, 2, 3, but request is demanded from the 103, P1 201 and P2 221 and needed from the 012. But 5, that means 5 requests need 5, so that means 121, so that means already filled, no problem. P2 need 012, P2 P2 P0 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 P2 no not issue, any option number C is I think correct, because it is full, because value is around I think yes, I need a fulfilled, no problem. Okay, so another problem are also given here, so you have see that into numericals and you have to solve the. And advantage of bankers algorithm, basically process are safe state form and executed financially, executed proper way, and no create the any deadlock condition. That is a part of the advantages, and the various advantages are here mentioned in these slides. So you have see that. And disadvantage, fixed numbers of process and no additional process can be started in the system while executing the process.